about 12 years ago, in March of 2006, John Caesar and Lisa Alexander and Russell Vose wrote this paper called Large-Scale Changes in Observed Daily Maximum and Minimum Temperatures, the Creation and Analysis of a New Gridded Data Set. So what they did was they used a technique to calculate daily temperature anomalies based on either maximum daily temperature, minimum daily temperature, relative to the baseline period of 1961 to 1990, which they call the reference period. In this paper, they go through all the details of how they do the calculations. So we're using this worldwide monitoring data set, temperature monitoring data set. This technique, which has quite a bit of math behind it, has been carried forward to the current day, and you can go onto GHCN and download the gridded data set. This data set then I used to try to visualize global warming from 1950 to 2018. So this is the original paper. These are the anomalies. You could read all about it if you like, but I wanted to show you the visualization of this. If you're interested in more detail of how I did this, you can go to my blog, datablends.us, and click on temperature anomalies, using temperature anomalies to visualize global warming using Alteryx, Tableau, and Mapbox. So this article gives you a detailed account of how I did this work. And so there's a preview of it. But let's take a look at the actual animation of these temperatures anomalies over time. So to start with, we're beginning in the year 1950. Upper left corner is January 1950. Lower right's December 1950. For every one of the panels, all 12 months of this panel, the cell sizes are proportional, with the maximum cell size being minus 32 and the largest being positive 32. So the same scaling for the size of the cells is shown in all the pictures. The coloring is the same way. The darkest, deepest blue is minus 32. The darkest, deepest red is plus 32. So when you're looking at this and you're watching these changes go over time, the size of the cells tell you the magnitude of the change of the temperature anomaly, as well as the color. So the combination of the color and the size is something you need to look at. And as we look here at 1952, we see that there's some big blue zones, some big red zones with pretty good intensity. January 1950 has the most intensity in terms of the temperature anomalies. That's what was used to set the scaling for this whole thing. And these temperature anomalies are set relative to the baseline period of 1961 to 1990. So as this animation goes, as I'm going to launch it now, it's going to step by year. It's going to go through year by year. And what you're going to notice is that the distribution of orange and blue and the intensity of the colors will change. Global warming is not what a lot of people think it is. It isn't like everything is heated up uniformly across the Earth. You have zones that are cooler than they were the year before, zones that are hotter than they were the year before, or relative to a baseline period. But the thing that you notice that when you're back in the 50s and 60s, you see, like we're looking at right here, lots of blues, lots of orangish red colors. You have a mixture of zones that are warmer and cooler than the baseline period. So we're now in the baseline period in the 1967 here. The baseline period goes all the way to 1990. And the thing that you're going to notice as this renders is that as we get into the 2000s and 2010s, the amount of blue that you see is far less than you see right now in the 70s, and you see more pronounced red. What that means is that there's heating going on across the Earth. And of course you see most of the grid points are in the northern hemisphere because that's where most of the monitoring on Earth is located, but you have southern hemisphere monitoring too in South America and Australia, South Africa. You can see those points, but So as this thing continues through the 1980s now, you're still seeing blues and oranges in pretty good proportion. We're in the middle of, or we're nearing the end of the baseline period here, which is coming up in a couple of years. Okay, so this is 1990. This is the end of the baseline period. It's a 30-year baseline period. We're animating 70 years, nearly 70 years of data here, 7 decades. There are approximately 68 million data points that's being rendered here month by month, year by year. Now we're approaching the year 2000, and if you just step back and you look at the distribution of reds and blues, you begin to see more pronounced big red areas. You see that in a lot of times in Europe, in Russia, in the northern latitudes. Now we're beginning to see some higher intensity reds showing up, which means there's more overall heating going on over large areas. We're in 2010, 2011 now. You notice, step back and you look at the northern hemisphere, certainly there's lots of red showing up. I think 2016 is a really hot year. You can see it pretty well coming up here. Lots of red right there. 2017, and now this is the final year, 2018. We're in July of 18, so it stops there, and then the animation pans back to 1950 here for the rest of the year. So high intensity heating going on. That's the full 69-year animation of temperatures. And if you were to pay attention and look at my blog, you would see that the month that has the biggest change is March. It has almost nearly a 4-degree Fahrenheit heating over the time period from 1950 to 2018. The time rate of change is about 0.06 degrees of F per year in the month of March, about half of that in July. So that's the story on global warming and trying to visualize global warming.